London Zoo, Timbuktu, can you help me find a clue? Woo-doo, where is... Oh, hey. So, what we're going to look at today is something known as component vector addition and or subtraction. What we've kind of previously talked about in some prior videos is we've talked about the idea of getting a polar vector. So if you have a vector at some angle from the x-axis, theta, we could break this up into a x component and a y component, if this is some vector v. And we could write this as just vx comma vy. That's the x comma y. That's rectangular notation. We've also talked about how we could take these numbers here in terms of a unit vector notation and say, look, this is the number of vx in the I hat direction plus whatever number we have for vy in the j hat direction. This is equal to vector v. And this is just x plus y. So it's just xy again, but just like that. That's our unit vector notation. And we also talked about in a prior video that if we're adding things up kind of on a fundamental way that we add vectors, if we just have a bunch of vectors pointing at different directions out into space, we're going from a starting position to an ending position, whoop, just like that. And it doesn't matter how we add these vectors together, the order that is, in the end we'll still always end up from the start to the finish. That is our resultant vector. The order doesn't matter, okay? So what we're going to talk about here is if we wanted to add vectors up analytically, how do we go about doing that? Well, here's how. Well, if we had vectors, and let's put them all into x comma y notation, this rectangular notation, okay? So let's put them in something like 1 comma 3, negative 2 comma 6, and then let's just pick another vector here, negative 1 comma negative 8. If you wanted to add these vectors together, it's actually very straightforward. You simply add all of your x values together and then add all your y values together, and that's it. So 1 plus negative 2 is negative 1, plus negative 1 is negative 2, and then over here 3 plus 6 is 9, minus 8 is positive 1. And this is your resultant vector. Okay, that's your resultant vector you have there. You just add the x and y components together. If we have something like in unit vector form, we do the same thing. In this example here, we have a boat that is going across the water. So when the boat is moving across the water like this, it's moving this way with some vector b. Its velocity is 3i hat plus 4j hat. But the water is also moving it to the left. So we can imagine here that the boat's not only moving forward across the river, but it's being pulled down and to the right. Why did I say left? That's weird. So if I kind of look at this, if I bring the c vector up and I put it like in a proper head tail, this would be vector c. And if we go start to finish, the way the boat's really going to travel is kind of like that. And you've experienced this at the beach before, like you kind of walk into the ocean at one spot and then the tide pushes you, or like the ocean currents push you down a little bit. And you can imagine if you swam across the river, you'd kind of be pushed further down the shore. So that's just what happens here, where this is, some actual resultant velocity of the boat we're looking for. And it's just the b vector plus the c vector, as we see not only here with the mathematics, but here with the head-tail method. So it's just vector v plus vector c. So to do that, we will just write out vector b. We know b equals 3i hat plus 4j hat. We know vector c is equal to 2i hat minus 1j hat, as we see up here in the problem. Here are vectors b and c. And if we're simply adding these together, then when we add them together, we once again add up the x directions and add up the y directions. Be careful about this negative right there. So 3 plus 2 is 5 in the I hat direction, and then 4 plus negative 1 is positive 3 in the j hat direction. And this is going to give us our resultant vector, which in this case is the speed of the boat. So if you want to add up many, many vectors together, get them into either x comma y or this unit vector notation, and then just add up all your x's, add up all your y's, or your I hats, j hats. And that's it. That's how you add vectors together analytically. It's actually really straightforward. Just add up all your x's, add up all your y's, call it a day. The somewhat time-consuming part is, you know, if we look back up to here, you would have to get each of these vectors into an x and a y for every single one. So if you're given a lot of stuff in polar notation, this can kind of get tedious. This one here is just y, so that's kind of nice. But in the end, once you do that, once you add up all the x's and all the y's, it's all straightforward and done for you, okay? So a really quick way of adding vectors together, adding them in components. And with that, x plus y's, or x's add together, y's then adds together, this is finished. So hope you enjoyed that. Adios, take it easy. On our next video, we'll be taking a look at how to do this in 3 dimensions. But until then, see ya.